Okay, I think we can start. First of all, thank you very much for coming. I'm not used to presenting with a mic like this. If I start to do this kind of stupidity, please just tell me. My name is Martin Woolley. I work for an organisation called the Bluetooth Special Interest Group. If you're not familiar with the SIG, as we like to call ourselves because it's shorter, we're the technical standards body behind Bluetooth technology. So we're responsible for the specifications, for the testing processes that manufacturers have to go through to demonstrate compliance. And we own the brand as well, so we do some marketing. Now, maybe you're already aware of this, but there are actually two types of Bluetooth technology. Something we now call Bluetooth Classic, and that's the original type of Bluetooth. Technically, it's called Bluetooth BR EDR. We kind of have two names for everything, a name for techies and a name for consumers. A newer version of Bluetooth, though, was released a few years ago, and for the consumers, we call it Bluetooth Smart. That's what we can see on the slide title there. But if you read the technical specifications, you won't see that name. You'll see the name Bluetooth Low Energy, and it's the same thing. And I'm going to use both terms just to confuse everybody, but hopefully I've defined my terms up front so you know where this is going. And this session is about Bluetooth Low Energy and Android. So what I'm going to do is talk about some kind of general things to give us some context and some kind of basic understanding of some theory. And then I'll kind of interleave theory with Android APIs and that kind of thing. Now, I'm also using a device on my arm here. This is not because I have some kind of like nasty rash on my skin, I'm trying to hide it. This is actually a Bluetooth gesture controller. So in theory, I will be advancing my slides simply by moving my hand in a certain way. Occasionally, I will move my hand in a certain way and advance my slides when I didn't mean to, okay? But that's called user error. So let's give that a try. Last year, there was a paper published by the investment banking group Goldman Sachs, believe it or not, talking about the future of the internet and the Internet of Things, and so on. And the author characterized the internet as having progressed through three waves. And in the first wave, we kind of created the fixed line internet with PCs. And there were about 1 billion PCs connected to the fixed wave. Fixed line internet in the first wave in the 1990s, the author stated. In the second wave, of course, we went mobile, and that brought 2 billion devices to the internet. But the third wave is the Internet of Things. And the forecast is that by the year 2020, there will be 28 billion devices connected to the internet as a consequence of this third wave, this incredible revolution that's actually kind of happening right now. You know, we're actually at the start of this incredible progression into a new world of connected devices. But Bluetooth Low Energy plays an important part in that. We like to say the killer enabler. Whoever you read, they'll tell you it's one of the key enabling technologies for the Internet of Things for a variety of reasons. And I'll kind of step through a few of them on the next slide. Behind the scenes, though, where Bluetooth itself is concerned, we've been experiencing enormous growth, kind of driven by this move towards the Internet of Things and some of the specifics that are happening under that heading. So things like wearables, beacons. Who's heard of beacons? Heard of beacons? Yeah, beacons are, I think, big news this year particularly. Last year it was time for some pilots and experiments. This year they're going to roll out. And more besides. So the original form of Bluetooth, Bluetooth Classic, came out in the year 2000. From that point on, we saw about 1 billion devices shipped by manufacturers every year using Bluetooth. That's a really big number. It's a very successful technology. In 2013, all of a sudden, there were 2.5 billion devices shipped in that year alone. A sudden acceleration. And last year, I can tell you there were over 3 billion. It's like 1 million devices a day being shipped. Numbers, 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 numbers. The point is, there's a big story happening here driven by all these kinds of factors. So I've already kind of made the claim that it's one of the killer enablers. Don't take my word for it. Go read some of the industry analysts. They'll certainly cite Bluetooth Low Energy is one of the key technologies. The great thing for you as Android developers, which I assume most of you are, is that for every new Bluetooth Low Energy device that hits the market, given that Android has good APIs for developing applications that interact with those devices, you have a big opportunity. You know, there are probably half a dozen applications you could write with some imagination for each new product using Bluetooth low energy that comes to market. So it's a huge opportunity for mobile application developers of all flavours. But this is Droidcon, so we'll focus on Android. So I want to briefly step through a few points about Bluetooth low energy before we move on, and then we're going to get to some code and a demo which may or may not work. We'll see. So one of the reasons Bluetooth low energy is a killer enabler for the Internet of Things is this low energy part. It was designed to use as little power as possible, and most Bluetooth low energy, or Bluetooth Smart as it's branded, devices tend to run off small coin-sized batteries about this big. And for that battery to last more than a year is very common. Months, absolutely typical. Year or years, quite common, because it was designed that way. There wasn't one single magic ingredient that made this possible. The kind of philosophy of low energy use is reflected throughout the architecture, throughout all sorts of design decisions, shaving a small amount of energy use off here and off there, such that we arrive at this ultra-low power wireless networking technology for small devices that tend to have sensors and emit small amounts of data periodically. The Internet of Things is not a thing. It's one of my favourite phrases. Probably should explain it. It means something to me. It might not to you. The point is, it's not a standardised, heterogeneous environment, nor will it ever necessarily be. There are a collection of different technologies involved in this emerging field. In and of themselves, those technologies have to be standards-based somehow, otherwise things will not work. Interoperability is central to the whole world of the Internet of Things. And interoperability between technologies will become increasingly important as well. So obviously, Bluetooth is a standards-based technology. The company I work for, Bluetooth SIG, our job is to manage that standards process so that manufacturers all implement the same way and things work together. Flexibility is important because without flexibility, we don't have innovation. Now, in the old days, going back in time 15 years to the original version of Bluetooth, if you invented a new type of device, you'd have to go through the standards process to have it adopted as a standards-based device, and it would be given a spec called a profile that describes that type of device, and then other manufacturers could implement according to that same profile. That's great in terms of making sure things are standardized and work, but not necessarily a quick process. One of the things that Bluetooth Low Energy was designed to enable was innovation, and so it's the building blocks of your devices and applications that are standardized, but you can assemble those building blocks in any way. So you can invent your own profiles, device types in other words, and still be compliant with the standards. So bring new things to market much quicker. Security is critical, of course, in the Internet of Things, although I'd like to qualify that and say that it's critical sometimes. Okay? Security doesn't always matter. The security requirements for a light bulb that you can control wirelessly from your smartphone are different to the security requirements for the wireless lock on the front door of your house, probably. So there's a range of possibilities where security is concerned. Bluetooth Low Energy has a range of security capabilities from encryption, where AES 128 is used, 128 bits is used to encrypt connections, so data is confidential, and a pairing process which has a range of approaches it can take. And pairing, if you're unfamiliar with it, it's when you first get a new device and you say, hey, smartphone, I want to use this new device with you, please trust it. Pairing is like a key agreement protocol, and it gives rise to the keys that are then used in situations such as encryption of the link. The latest version of Bluetooth is 4.2. The specification was released in December last year, and this introduced the use of elliptic curve Diffie-Hellman, the key agreement protocol, which is using a public-private key pairs, very, very secure. Secure enough to be FIPS compliant. Who's heard of FIPS? Okay, one person. Okay, so FIPS is the Federal Information Processing Standards. It's a US government specification that says if you're going to deliver IT solutions to a US government department like the military, these are the requirements you must meet. Very stringent. And Bluetooth Low Energy is FIPS compliant, or devices based on it can be FIPS compliant since 4.2 and the changes we made there. Everyone hear me at the back okay? Yeah? Oh, no one's nodding, so that means no. Can you hear me at the back okay? Thank you. Okay, developer friendly, well, you can be the judge of that. We'll come to that in a moment. It was designed to be developer friendly. Manufacturers then go on and build their own APIs on top of our architecture, and that's what we'll see regarding Android. And pervasive, you know, choosing a wireless networking technology for your product, which is one which isn't used by many other products, is probably a brave decision. You know, you need to choose something which is pervasive. Who wants to be the only person on the planet with a telephone? It's not very useful, right? By the way, several people have telephones these days, I'm told. Okay. Internet connectivity as well. We made some announcements in December last year also around the 4.2 specification that illustrated how we'll be releasing some new specifications soon, this year, which enable Bluetooth Low Energy devices to be connected to the internet in a number of ways. Support for low power IP over Bluetooth as transport is coming. So Bluetooth devices then get IP addresses. And there are two ways in which HTTP can be used to map onto Bluetooth operations. So I could, for example, use my smartphone and HTTP via a gateway device to discover all the Bluetooth devices in my home securely and then interact with them. Maybe I've got sensors on my doors and windows. I can check the status of them. Are they open or closed, locked or unlocked? Similarly, devices inside somewhere like the home can post data over Bluetooth, which is then mapped to HTTP. So maybe I've got temperature sensors in the home, and they can post temperature readings to a cloud-based energy efficiency service, which does some form of analysis. So connecting Bluetooth devices to the internet is possible. In a standardized way, by the way. So I think one last thing before we move into, I've got a demo which I'm really looking forward to now, given the way this started. I'll take questions at the end if that's okay, by the way. There are an increasing number of wireless devices in any given environment. There are, I don't know how many in this room right now, lots of them, using a variety of wireless networking technologies. There is the possibility for interference. There's the possibility for degraded performance. Bluetooth uses something called adaptive frequency hopping to help mitigate this risk. And the way this works is that rather than transmitting and receiving on a fixed frequency or set of frequencies like Wi-Fi does, the frequency used is adapted to the environment the device finds itself in. And it can change hundreds of times a second. So you can imagine Bluetooth traffic kind of weaving its way through a crowded room full of radio transmissions. Bluetooth is a radio technology. And it works in something called the ISM bands. That's the industrial, scientific and medical part of the radio spectrum. And this matters because ISM is really, really, really popular because ISM is free to use. It's not like 3 and 4G where you had to spend huge amounts of money to get access to that part of the spectrum. It's free. So it's very popular. Bluetooth uses it, Wi-Fi uses it, microwave ovens use it. So, you know, if you work in a microwave oven factory or something, you know, that can be quite a congested environment, but Bluetooth manages to find its way through that kind of situation with its adaptive frequency hopping capability. Okay, that slide there very cleverly means that I'm going to go deeper into the technology now. You can see there are some binary numbers, that's what that means. So I'm going to start with a demo. And whether it works or not, whether I end up throwing things across the room or not, hang on, we'll then proceed to talk about how it works. Now, unfortunately, another thing that's not working is I can't show you what's on my smartphone screen today. Since I upgraded to 5.1, my screen sharing software stopped working, I discovered this morning. But anyway, what I'm going to do is use this application. You probably can't quite see it at the back there, but I have a UI with some buttons, okay, just like any other application. I'm going to press one of those buttons now, and oh look, I switched on some lights using my smartphone, using Bluetooth Low Energy to send commands to the light, of course. Well, I can change the colours. That's a nice pretty red colour, and that's a slightly colder blue colour. And I know it's moderately early in the day for some of you still, not used to being up at this time maybe. Any students in the room? Yeah, I thought so, yeah. This is what morning looks like, okay? But we can have a disco as well. So there we go. Let's stop the disco before anyone has some form of fit. I get sued. So, quick swig of water. So let's consider what we just saw and think about how this worked. Let's be engineers now. And then we'll start to talk about Android applications like that and how you can write them. What we have here is a client-server architecture. So immediately we're in familiar territory. In this case, the client was my Android application, and the server was the set of LED lights. Now, how can a set of lights be a server? That doesn't make any sense, I thought when I first heard about this kind of thing. Well, the answer is that it's not just a set of LEDs. Somewhere lurking down on the floor just there where you can't see is a small box which has an on-off button on it, but it also contains some hardware. There's a chip in there, and the chip is running some firmware. Okay, the chip is basically a microcontroller unit with a Bluetooth Low Energy interface, and it's programmable because microcontroller units tend to be. They need to be. That's what they're for. The code is running. It was written by an embedded software engineer, I guess, probably in C, C++, something like that. We don't care though, because we're Android developers today. All we care about is that it's exposing a server interface of some sort, and that server interface allows me to send commands via some part of the Bluetooth Low Energy architecture, something called the attribute protocol actually, which we'll learn a bit about later on, so that I can give it instructions. Switch on, switch off, change colour to red, change colour to blue, and so on. So armed with the APIs I get with Android, the Bluetooth stack that's on my smartphone, and the interface exposed by that embedded software engineer on top of the Bluetooth stack on that set of lights, I can do the things that you saw. And that general principle holds true for every Bluetooth Low Energy device. You just need some information, and you can start inventing applications that work with those devices. So let's move on. We'll start with some theory. Typical Bluetooth Low Energy smartphone application will have a certain structure. You'll tend to start off with some form of discovery process where you're searching or scanning for devices that are in range and that have certain capabilities. So imagine I have an application that's supposed to work with my heart rate monitor. Let's imagine for a moment that I'm into fitness, I'm into running and cycling or something, and I have a heart rate monitor. I want to use my phone to give me some statistics, to draw some graphs, to tell me when I'm about to have a heart attack and I should stop, that kind of thing. But I need to find my heart rate monitor. So I'm at a race, I'm surrounded by 100 other athletes. I've never done this, by the way. This is someone else I'm describing here. So the first thing I'll probably do is fire up my application. It's going to scan for heart rate monitors, list them on the screen, probably in order of the ones that are nearest to the phone. So the one at the top of the list is probably mine. And I'm going to select it and say, yeah, that's the one I want to work with. We'll then connect to it, and then we'll interact with that device. The discovery process is governed by a part of the Bluetooth Low Energy architecture called GAP. That's G-A-P, the Generic Access Profile. So Bluetooth is a stack. It has a structure. There are component parts to it. That's the architecture, and GAP is one of them. And amongst other things, it's concerned with this discovery process. And the way it works is that according to GAP, devices have to have one of 4 possible roles. And essentially, they kind of fall into 2 categories. Either a device wants to be discovered, in which case it does something called advertising. It emits small packets of data periodically, maybe every 100 milliseconds as an example, and that packet includes details of the device, its identity, a MAC address, and some hints about the kind of things that it can do. You might say who the manufacturer name is as well. And you can use that information to decide whether or not that device is relevant to your application. And meanwhile, on the other side of the coin, and by the way, sorry, that's called a GAP peripheral. That's the name of the role. The smartphone device takes on the role called GAP central, and its job is to find other devices to connect to. And it initiates the scanning process, receives advertising packets, filters out the ones it doesn't like, selects the ones that it does like. So that's how GAP works. So there's advertising again. If you're receiving advertising from a device, A, it means it's in range. If it wasn't, you wouldn't receive the advertising packets, obviously. It contains some information about capabilities. And in the case of beacons, beacons are a special case of advertising Bluetooth Low Energy device, small transmitter. They also contain an identifier, which you can then map to a physical location. So physical location might be a coordinate pair, or it might be a store ID and the department ID. I'm in the sporting goods department in the store in London. So that's how beacons work. If you receive advertising packets with the given ID, you can deduce from that that the user is within a certain range of that beacon in that place, and then take some form of action which is relevant to that beacon's location. I think I'm way behind schedule. I'm going to speed up a bit. So here's our first look at APIs. To kick things off and discover devices, what we're looking for is a list of Bluetooth device objects. That's what we want. To kick things off, we need to get ourselves a Bluetooth adapter object, and we can initiate scanning using that object. To get that, we use this thing called the Bluetooth Manager. So you can see the code there, where we get Bluetooth Manager by calling get system service, and from that we say get adapter. We're now ready to start scanning. To kick off scanning, look at the bottom of the screen. You can see I call start LE scan, and I have a reference to another object passed as an argument, and that's an interface called LE scan callback. So basically, as advertising packets are received, devices are discovered, I'm going to get a callback to my implementation of this interface, and it only has, well, we'll see the interface in a moment. It has one method. It's very simple. Now, typically, you're going to scan for a few seconds only. It's going to use some battery, so you want to be careful with that. So I'm using a handler here to post the delayed execution of a call to stop LE scan. So in this case, I'm saying start LE scan at the top of the bottom of the screen, but prior to that, I've set up the delayed call to stop LE scan 5 seconds later. So I scan for 5 seconds, I'm getting callbacks. I populate a UI, and then the user decides how to proceed from there. So there's the interface. Just one method on LE scan. I receive a Bluetooth device object as one of the parameters. I also get this thing called the RSSI. That's the received signal strength indicator. In other words, it's the signal strength. And I can deduce from that, in relative terms at least, how close or far away a device is. You know, a strong signal means it's probably quite near. A weak signal means it's probably not very near. Although, note the use of the word probably. It could also mean that there's a wall in between me and that device. Okay? But you know the circumstances your application will be used in. And the byte array is the advertising packet in full, which you can dig inside and parse out other details. So that's the discovery process. Scan, filter, populate a UI. Second basic concept is that of device state. So according to Bluetooth Low Energy, all devices have state, like a state machine inside them, and that state data is really what you want to discover and work with from your application. So state data might be a temperature reading if the device has a temperature sensor, could be the battery level, could be the model and serial number of the device, and so on. The one I've not mentioned, notifications, is an example of a capability the device might have, but which is controlled by a state variable whose job is to let me configure the behavior of the device. So I can switch things on and off via that state machine as well. For the discovery process, we introduced GAP, the generic access profile, part of the architecture, concerned with discovery. Once we're in a connection, we're going to work with something called GATs, and you'll see GATs in all of the Bluetooth Low Energy API class names in Android. So this is where it comes from. It's the generic attribute profile. And according to GATs, we have a client and a server. The server has the state data that we want. The client is exploring and using it. Behind the scenes, implemented in the stack on your device and on the Bluetooth lighting system, whatever it is we're working with, something called the attribute protocol is used for communication between the devices. That's part of the Bluetooth stack. You guys don't need to worry about that. It's done for you. That's annoying. Let's get rid of that. Please, thank you. Oh, come on, work. There we go. So you don't need to worry about implementing protocols and demarshalling and marshalling and all that horrible stuff. It's behind the scenes. It's encapsulated by your APIs, and it's in the stack on your device. But that's how it works, and it's worth bearing that in mind. The state data itself, it's not a random jumble of bytes that you have to decode. GAT defines a hierarchical structure for that state data. And at the top of the hierarchy, we have things called services. So services are like collections of related state data. So for example, There's something called the battery service. There are a number of services defined by the Bluetooth Special Interest Group. We call them adopted services. So think of those as standard ones if you like, but we prefer the term adopted, and hopefully the reason for that will become clear in a moment. So amongst those adopted services is the battery service. Very common for these devices to have batteries, very common therefore to want to know what the battery level is, and the battery service lets you determine that, because battery level is a state data item encapsulated by that service, and you can query it. There's also something called the device information service. It's quite common to want to let applications discover what the name of the device is, who the manufacturer is, what the serial number is, and so on. They're all contained within that standard service called the device information service. But you can invent your own. If you're a firmware developer, or in fact if you're an Android developer, and I'll come back to this much later on, you can invent your own capabilities that your device has that make it special and implement custom services. And you're still in accordance with the spec, because it's the building blocks that are standardized. You can use those building blocks in a variety of ways. Drilling down on services, those individual items of state data inside a service, we call them characteristics. And a characteristic has a type, represented by a UUID, and it has a value, and potentially some other things as well. It may have associated with it something called a descriptor, and a descriptor is like metadata. So it tells us something more about the characteristic, or it lets us configure it in some way. So it's a three-level hierarchy. That's the model, and the APIs in Android reflect this. I just mentioned UUIDs. So 16-bit UUIDs are allocated to all of these characteristics and services that the Bluetooth Special Interest Group define. If you want to invent your own, you have 1 to 8-bit values you need to use. You need to avoid the range that we use. UUIDs represent a type. Remember that. Sometimes you can have multiple instances of the same type. You could have more than one battery service if you have more than one battery in your device, for example. They would have the same UUID and different handle values to differentiate the two instances of that service. Hope that makes sense. So let's look at some code again. So now we're going to look at what we do to connect to the device and then explore its GATT state model. And by the way, one last thing. Services, characteristics, and descriptors, generically, they are all GATT attributes, hence the generic attribute profile, and hence the attributes protocol. They're all attributes of different types and different levels in that hierarchy. So, we've already seen these classes, used them in discovery. Not surprisingly, what you just heard, we've also got classes that represent services, characteristics, and descriptors, named, as you can see on the screen there, Bluetooth GATT. You know what GATT is now. And there are these two classes as well, which you'll use all the time. Bluetooth GATT's like a controller object, and I use it to initiate operations, kind of give it commands. We do various things with services. We can access them directly if we know their UUID, or we can enumerate them. We can get lists. We can say, give me all the services that this device has. To do that, we call this method discover services on that Bluetooth GATT object. Remember our controller object that we give all our commands to. Discover services is just kicking off an asynchronous operation. So the attribute protocol are kind of talking to each other behind the scenes, and eventually when the device has replied with information about the services it has, we get a callback to on services discovered. And from there we can call get services as opposed to discover services, and that gives us a list of Bluetooth GATT service objects. So now we know what services our device has. We can go direct by UUID as well, and here's an example of one. There's, you can get these devices you attach to your keys, so that if you lose them, it'll alert you if you walk away from them, or if you can't find them, you press a button and it makes a noise. That's called the proximity profile, and it has something called the immediate alert service in it as well, and I can use that to tell the device, make a noise because I can't find you. So I know it's UUID, I know I'm going to need to work with that service, so I can just call get service, and quote that UUID, create a UUID object from a string. Characteristics belong to services, remember that. So it's a hierarchy, it's a containment structure. So if I want to work with a particular characteristic now, and a characteristic, remember, is one of those data items, I need to start with the service. So once I have that service, I can do things like say, well, tell me what characteristics you contain by calling get characteristics. I can also go, once I've got a particular characteristic, I can read its value. And I do this by calling the read characteristic method on my Bluetooth gap controller. This is asynchronous once again, so I'm going to get a callback. And the callback is to this method on characteristic read, and it includes a reference to my characteristic. And then I have a variety of getter methods, which I'm going to use according to my expected type that the value of that characteristic has. So you can see there I'm using get value. On my slide, that just gives me a byte array, and I can do whatever I want with it then, but I have things like get string value, get int value, and so on. So it's pretty straightforward. Read characteristic, get callback, use a getter. But behind the scenes, lots of magic is happening. Writing characteristics, that's easy as well, and you're going to need to do this from time to time, or you're going to want to. Once again, we have to start with a characteristic object, but then we issue a write characteristic command against it. A once complete, the remote device has received its new value for that characteristic and replies, thanks, I'm done. We can check the outcome. We have a status value in the callback that we can check to see if it worked. I want to talk a little bit more about the attribute protocol now. Once again, though, you don't need to know a lot, but some things make more sense if you know a little about it. There are 20 or so kind of protocol data units or actual message types in the attribute protocol. You don't need to know the names of any of them. If you're a firmware developer, you may need to. From our point of view, they kind of fall into 6 categories. We have requests and responses, which go together. A request is sent by the client to the server, and a response is expected. If we don't get a response, we'll consider that a timeout if it doesn't come back in a given maximum time. Whilst we're waiting for that response, we can't do anything else. But we also have things called commands. The client can send a command to the remote device, and that's like a fire and forget operation. We don't want a reply, we don't expect a reply, we don't have to wait to do the next thing. We can just send a command and move on to the next operation. That's all client to server initiated interaction. But we can go the other way as well. So servers, like the lighting product, they can send things called indications to the client. And in the case of an indication, a reply is expected. I want to know that you received that indication which contains a new value or something. So the response to an indication is called a confirmation. That's a type of message. And finally, and the whole reason really I'm telling you this, we have things called notifications. And notifications are like commands in the other direction. Okay, so server devices like the lighting product or a heart rate monitor can send data asynchronously to a connected device like a smartphone using these notification message types. They don't expect a reply. They're used very commonly, which is why I've picked this one out. So heart rate monitors measure your heart rate using some magic around your chest, but whenever they have a measurement, they emit a notification to send a new measurement, maybe once a second, as a Bluetooth low energy notification, and your application is going to be receiving that data and using it to draw a graph on the screen or something. You encounter these things a lot. So let's look at how you use them. Okay, yeah, I'm over time. Well done. I'm nearly done now. So it's kind of 2 stages. Notifications have to be switched on. You won't get them unless you switch them on. And there's like a local stage to the process and a remote stage, which involves the actual remote device. In the local stage, first of all, you're switching on notifications with respect to a specific characteristic. So for heart rate, there's a thing called the heart rate measurements characteristic. That's the value measured from your heart at that moment. And once you have an instance of that characteristic using the UUID, you just call set characteristic notification with that as an argument, and the true value means please switch on. You've just made the local stack ready. You've registered an interest in notification messages relating to that characteristic in the local stack. You haven't yet told the remote device, so the heart rate monitor doesn't know that you want notifications yet. So that's the second stage, that's the remote stage. And this is the first time we use descriptors. So descriptors are metadata associated with characteristics, but they can also be used for configuration purposes. And there's a special type of descriptor with a wonderful name. It's the client characteristic configuration descriptor. Try saying that quickly. and its job is to allow you to do things like switch on and off notifications and indications. So we grab an instance of that descriptor using its UUID, and the UUID it's on the Bluetooth SIG website, by the way. All these standard ones are there, plus there are constants defined in the in some of the Android API. We set its value, and we have a figurative constant available to us called enable notification value. I can tell you the value is actually 1 for on and 0 for off. And then we call write descriptor. So now what we're doing is we're initiating a transfer of that value over the attribute protocol wirelessly to the heart rate monitor, not the lighting product this time, the heart rate monitor, which will receive it, and it will switch on notifications for the heart rate measurement value. And now, every time it measures the heart rate around my chest, it'll emit a notification. And I'm going to receive that notification message as a callback to on characteristic changed. So I'm going to get callbacks to this thing every second or something like that, and it's now over to me to do something sensible with that data. I get a characteristic object, and as you saw, extracting the value from that characteristic is very easy. I'll just call get value or get in value or something. And you'll check the spec to determine the format of the data in that characteristic. So it's pretty straightforward. Android L made some changes, quick summary of that. And I hinted at one of them earlier on. So wind your minds back to the discovery process. So remember we had some roles. We had a part of the architecture called GAP, the Generic Access Profile. It's responsible for discovery. The devices have a certain role to play. They're either GAP peripherals, so they advertise and say, hey, I'm here, please discover and connect to me. Or GAP central, which means, hey, I'm looking for people to connect to, and I do the scanning. Android L switched things on its head, and it's now possible for an Android application to be a GAP peripheral. And this is, I think, fairly mind-blowing, because what it means is that Android applications on an Android smartphone start to be like virtual Bluetooth peripherals, hosted in the same physical container. So your mobile device is like the physical hosting environment, but we can have multiple applications all acting quite separately as kind of emulated virtual peripheral devices, all advertising with different advertising packet content, all available to be connected to via some other device. So think about what you could do with that. Okay, nearly done. If you want to learn more, going hands-on is the best way always, of course. Sitting listening to me, maybe not. Go to our website. We have a developer portal, developer.bluetooth.org. I'd recommend this thing. It's called the Bluetooth Smart Starter Kit. How many of you have or have played with Arduinos? Lots of you, okay. It's loads and loads and loads of fun. So our kit is a kind of self-teach set of resources. You provide the hardware. You have to get yourself an Arduino with a Bluetooth Low Energy shield, and you need a phone. And we provide you with some labs and source code, and you can go through that and teach yourself how to write Bluetooth Low Energy applications for Android or Windows Phone or BlackBerry 10 or iOS, whichever you prefer. Questions in a bit. So it's a great way to learn. It's free to download our stuff, but you'll need to pay for the hardware. So the phone is you know, anything from, I don't know, a small number to a really big number, if that's specific enough. Arduinos, how much are they now? 25 euros or something? An Uno? Yeah. Not sure about the shield, but I have some to give away. Which brings me nicely to this slide. I do have some developer kits. I've got a couple of devices. The one at the top is a Texas Instruments sensor tag. It's a Bluetooth Low Energy transmitter. It has 6 sensors on it: temperature, humidity, motion, various things like that. Great way to have a thing on your desk you can program against and learn about it. It can also behave as a beacon if you're interested in beacons. There's a Droidcon Wicked Sense, which is essentially the same thing. I think it's also got 6 sensors. I think it's a very, very similar device, great to test against and learn about. And finally, we've got Bluetooth Low Energy Shield for Arduino. And one of these items could be yours, and all I want you to do is follow me on Twitter and tweet something which I like over the next hour. The rules are really imprecise because even I don't know what they are. I have no idea. So something deeply profound about the future and IoT and Bluetooth Low Energy, or frivolous and funny, I really don't care. If it grabs my attention and I think it's cool, I'll make contact, we'll meet up, you can select from whatever's left at that point in time. Make sure you put my Twitter handle, Bluetooth_MDW, in your message. Make sure you follow me, otherwise I won't know and I won't be able to contact you. Thank you very much for listening and your great questions.